equals 88. And what number plus 4 equals 226? 222. Now, what element is element 86? So we go to our periodic table, element 86 is Rn, or radon. So what we have done is we have transmutated, that's the fancy schmancy word. We've turned radium into radon. So you can make new elements through these types of reactions. Do you have a question, Jared?
No.
Maybe let's do one more. How about we do, fine, let's do polonium. Polonium-211. Is polonium radioactive? This top number can change. That's where I was saying you have to be given the top number. So I've got polonium-211. I made it up. The top number, the mass number, has to be given to you in the problem. The bottom number will always be what it is on the periodic table. So is polonium radioactive?
Yes.
Yes. Okay.
Is it always foreign too?
The alpha particle is always 4 and 2. So then, what's the bottom number here? 82. What is element 82? Lead. What is the top number? 207. Is lead radioactive?
No.
No. So, in the first example, we have radium. That's radioactive. It becomes radon. Is radon radioactive? Yes. So things will keep decaying. Radium becomes radon. Radon will become polonium. Polonium will become lead. And then, is lead radioactive? No. And then the radioactive decay stops. So you can start with something radioactive. Eventually, it will no longer be radioactive. Now this takes sometimes years, sometimes decades, sometimes thousands of years for this to go through this process to get to a point where it's no longer radioactive. Okay. Yep, Alex.
When you say like it could take years, is that for like each individual atom? Particle?
Yeah, yeah. And again, the bigger your radioactive sample, the longer it'll take for that sample to disappear and become non-radioactive.
So could it be different for like each individual particle then?
Yes, but it's, and we'll get to the equations later, but an example would be, suppose I have 1,000 pennies, and I'm going to throw them up in the air, and every time they land heads, I'm going to remove them. Well, how long would it take until I would remove all the pennies? Okay, well, there's a certain chance that I could throw 1,000 pennies up and they'd all land heads and then we'd all be done, right?
Yeah.
Is that likely? No. The same thing here is, I mean, could this go quickly? It could. Could it take a long time? It could. But you base it on probability and say, well, what's the most likely option? Flipping 1,000 pennies and removing the heads is going to take a long time. And we'll get to those equations later where we can actually calculate the time it takes for things to disappear or decay. I shouldn't really use the word disappear because they're not really disappearing, John. They're turning into something else, okay? The polonium's gone, but in its place now you have lead.
Where does that alpha particle go?
The alpha particle is shooting through the air.
Just gone.
It goes, phew, there it went. And I will show you the radiation with a cloud chamber. That gets a little bit difficult to show, but I've got some radioactive polonium, actually, as it is. And what's it doing is it's detecting the alpha particles. You can't see them, but the alpha particle hits the metal, creates an electrical current, and makes a click. So every time an alpha particle hits it, now they only sell me a small amount of polonium because in large concentrations, if you put it in someone's food, you can kill them. So they're not going to sell me large amounts of polonium. So don't be freaking out here like, oh my God, Mr. Strauss said radioactive stuff in class. It's very, very, very out, look, I'm pointing at myself, okay? I'm not worried, right? The amount of radioactivity is extremely, extremely tiny. We'll talk more about, we're running out of time, we'll talk more about this tomorrow, but there was just recently a couple of Russian defectors who were poisoned. Or supposedly poisoned in case people in Russia are listening right now. Supposedly poisoned. Please don't get angry at me in Russia. I love Russia.